Welcome to Maths with EJD. In this video, we'll be talking about frequency distributions and cumulative frequency. Interestingly, I believe this should have come way earlier, like it should have come before we started considering center measures of central tendency and things like that. But I mean, it's fine. Let's be on record that this should have come before we started working with grouped and ungrouped data because this is really useful in that regard. So let's move on and talk about frequency distributions. First of all, frequency distributions. A frequency distribution is a way to organize and summarize a set of data by showing how often how often each value each value or range of values occurs. Okay, so it helps in understanding the distribution. It helps in understanding the distribution of data and identifying patterns. Okay. All right. So that takes us to consider types of frequency distributions. We have encountered this a lot of times before now, and that is why I feel this particular topic should have been treated immediately after, I think, data collection and sampling before measures of central tendency or location, right? So types of frequency distributions. First of all, we have ungrouped, ungrouped frequency distribution, ungrouped frequency distribution. Okay. So in this case, each value, each value is listed along with its frequency. So here we just have a single value, right? An example of that would be something like this. Example, consider a survey of the number of books, of the number of books read by a group of students, by a group of students in a month. Okay. So here now we have books read, and then we have the frequency. So here we have those who read 0 books, we have 2 of them. Those who read 1 book, 5 of them. Those who read two, 8 of them. Those who read three, those who read two, uh, those who read two, right? 8. Those who read three, 3 people read 3 books. Then 2 people read four, 2 students read 4 books. So this is ungrouped data, ungrouped in the sense that we have the number of books is just just 0, 1, 2, 3, 4. Not like 0 to 4, 3 to 2 to 7 or something. No, just single values like this. Okay. So you have each value listed alongside the frequency. That is what ungrouped data, ungrouped frequency distribution is about. We've encountered it a lot in our previous uh, talking about measures of central tendency and all the calculations we've been doing all along, we've had to deal with both grouped and ungrouped. So this is ungrouped now. You have just a single value with its frequency. So let's move on to grouped frequency distribution. We've talked about ungrouped frequency distribution. So now two grouped grouped frequency distribution. Okay. So number one, we have what we call, so here, data is divided into intervals, into intervals or classes. And the frequency of data points within each class is counted. Within each class is counted. Okay. So example, suppose suppose we have the following test scores for 20 students. So see how that goes. We have score range. Now it's not just a single score, now it's a range of scores. So maybe we group the scores together, score range and frequency. Of the score range and frequency. Uh, so 0 to 49. How many people scored from 0 to 49? We have 4. 50 to 59, we have 5. Now, these are the things that make this one grouped, right? You have a range of scores, not just single value like in the case of ungrouped data. So 50 to 59, 5 people scored between 50 to 59. 60 to 69, you have 6 people scoring that. Then you have 70 to 79, you have 3 people scoring that. Then you have 80 to 89, 2 people. Then 90 to 100, 0. Okay. 90 to 100, you have 0 people scoring that. So so you could actually take, interestingly, right? You could take, you could make ungrouped data into grouped data. Basically, so that's really possible. For instance, if you had, so I mean, so I've made this group now, it means that 4 people would have scored any score from 0 to 49 randomly. Probably by the time you're taking all the scores, you have maybe someone scored 35, another person scored 40, another person scored 36, another person scored 48, making 4 of them like that. And then by the time you want to group, so once you just define your interval, so everything just falls in line with that. So that is how this can go. So that is for ungrouped. I mean, that's for grouped frequency distribution. And just like I said now, okay, maybe I should just demonstrate what I said. Uh, so let me say, is it transforming? Making ungrouped data, ungrouped, making ungrouped data into grouped. Okay, or should I say, is it data now? Making ungrouped into grouped distribution. Yeah, into grouped distribution. So I think it's important to demonstrate that. So consider consider the following test scores, the following test scores for 30 students. Okay. Say you have, just going to get the numbers randomly. Say you have 95, you have 60, you have 70, you have 72, you have 54, you have 32, 1, 2, 3, 4, 5, 6. You have 24, So that's a 1, 2, 3, 4, 5, 6, 7. So you have 56, that's 8. You have 81. You have 1, 2, 3, 4, 5, 6, 7, 8, 9. And you have, say, whatever, 45. Okay. That's 10, right? And we're going to 30. So let's say next you have 59. You have 11. You have 22. You have 64. You have 71, you have 22, you have 33, you have say anything, 65, you have you have 19, you have 62. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. One row to go. Then you have now, say you have 20, 32, 47, 53, 65, 78, 86, 91. Uh, say you have 31 and 42. Okay, so you have this 30, right? So the way it is now, this is ungrouped data. So this is ungrouped data. You just have the values one after the other like that. So you can make this into this is on group data rather. You can make it into grouped data, you know. So, and that is what we want to do next. Okay. So we can now have again, you can have like a score range, and then you have the frequency. You have a score range and you have a frequency. So this is how that goes. Then you have to decide your range. You have to actually decide your range. What range do you want to go for? So do you want to do, okay, let me choose 0 to 10. You have 0 to 10. Okay. Then you have 0 to 10, 11 to 20. Okay. 21 to 30, 31 to 40, 41 to 50. Oh, this is a lot. Okay, but it's okay. Let's just do it. Then 51 to 60. And then we have 61 to oh, I think this is too much. Let me shorten it. Let me make it into 20 so we don't have to go all this far, you know. So let me just do like of course it depends. You have to choose based on what you are interested in, what you want to find, right? So let's do to make it faster, 0 to 20, good. 21 to 40, 41 to 60, then 61 to 80, and then 81 to 100. Okay. 81, 81 to 100, like this. So to deal with that, right? 0 to 20. So you have to mark out everything that is anything from 0 to 20. So you have anything like none in row one, but we have this one, two, no, 0 to 20. Sorry, 0 to 20. So this is 11 is part of that. 19 is part of that. What else? 20 is part of that. I think that's all. Now, one trouble with this is if you're in an exam situation and you have to do this, you have to be really careful because you can overlook something and then once it's not complete, you may have to keep checking and be sure. So 0 to 20, I think that is all we need for 0 to 20. I believe so. Yeah. So the frequency of 0 to 20 is 3, right? 3. So that's gone. So the next thing we need is 21 to 40. Let's see 21 to 40, 21 to 40. So this is part of that. This is part of that. 21 to 40. 22 is part of that. 22 is part of that. 33 is part of that. 21 to 40. 32 is there. 31 is there. I think that's about all. 21 to 40. Yes. 21 to 40. 21 to 40. Okay. So that's 1, 2, 3, 4, 5, 6, and 7. I believe so. Hope we've not left anything out. Yeah, I think it's fine. 21 to 40 is 1, 2, 3, 4, 5, 6, 7. So 21 to 40 is 7. Okay. The next one is 41 to 60. 41 to 60. So now 41 to 60. 41 to 60. So this is part of it. That's 45. 59 is part of it. 41 to 60. 47 is part of that. 53 is part of that. 42 is part of that. That's 41 to 60. Would that be all? 41 to 60. 41 to 60. I think so. 41 to 60, that's 1, 2, 3, 4, 5. 41 to 60, that's 5. Okay, next, you have 61 to 80. 61 to 80. Oh, 41 to 60, right? This is part of it, sorry. 60 is part of that. 41 to 60. So that's 1, 2, 3, 4, 5, 6. So that's 6. That's 6. So that is actually 6. Okay, so 61 to 80 now. 61 to 80. 61 to 80. So 70 is part of that. 72 is part of that. Aha, you can see the trouble. I can see 54 now. 54 should be part of 41 to 60. So it's very easy to make mistakes here. So we already had 6, right? So 7, 8, right? For 41 to 60. So that's, oh wow. Yeah, that's 41 to 60. Yes. So that'll be 8 now. So you see that? It's very easy to make mistakes here. 41 to 60 is 8. We may still discover something later, right? So now we are doing 61 to 80. 61 to 80. That's 1, 2, 61 to 80, 3, 4, 5, 6, 7, 8. I think 61 to 80 would be 8. 61 to 80 is 8, right? That's 1, 2. Look at the boxes. 1, 2, 61 to 80. 3, 4, 5, 6. Okay, that'll be 6 for 61 to 80. Then 81 to 100, of course, will just be anything that has not been touched so far. So that'll be 95, 81, 86, 91. I think that's all, I believe. So 1, 2, 1, 2, 3, 4, I believe. Yep, that should be 4. So, but how do you know if you're correct? You have to check. 3 plus 7 is 10. 10 plus 8 is 18. 18 plus 6. 18 plus 6 is 24. 24 plus 4 is 28. So something is wrong somewhere. Something is really wrong somewhere. Uh, what have we done wrong? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So let's do it again. Uh, 81 to 100. Was that correct? 1, 2, 81 to 100. Uh, 3 and 4. Okay, that's fine. So this is 14 plus 8, 22. 22 plus 10. No, what is wrong here? 4 plus 6, 10. 18, 25. So 2 have not been accounted for. Two have not been accounted for. So 80 to 100 is 81 to 100 is 1, 2, 3, 4. Okay. Okay. 0 to 20 again. Let's check. 0 to 20. Okay, let's start from the back. 81 to 100, you have 91. 81, that's 2, uh, 3, and 4. Maybe that's correct. Then 61 to 80. 61 to 80. 61 to 80. That'll be 1, 2, 2, 3, 4, 5, 6, 7, 8. 61 to 80. 61 to 80 is 8. Okay. Ah, 61 to 80 is 8. All right. 61 to 80 is actually 8. Yeah, I think that's where the issue is. So let's check that again. So I actually have 8 boxes. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. So that's 61 to 80. Good. So now I think we are good. 3 plus 7 is 10. 10 plus 8 is 18. 18 plus 8 is 26. 26 plus 4 is 30. So now we are fine. Okay. So in an exam situation, you need to be very present. Like your uh any distraction can lead to trouble. So you can actually change ungrouped data to group data like this. Of course, you have to fix your range if you're not given any, but most times for uniformity's sake, you'll be told to choose your range. Okay. You'll be told to choose your range. So that's how to convert from ungrouped data to grouped data, and that comes in very handy most times. So let's go ahead and talk about cumulative frequency. Cumulative frequency. So, we have talked about frequency, right? Frequency is the number of times a particular data point occurs, whether it is in group data or group data. So, but the idea of cumulative is summing up those frequencies, right? So, for cumulative frequency, see what we get. Cumulative frequency is a running total. It is a running total of frequencies. We've done this a lot with all the different measures we've been doing so far. So cumulative frequency is a running total of frequencies. Simply, it's a running total of frequencies. So it adds the frequency, it adds the frequency of, it adds the frequency of a class to the sum, to the sum of the frequencies, to the sum of the frequencies of all previous classes, of all previous classes. I'm going to demonstrate that, so not to worry, of all previous classes. In fact, we've done that a lot previously. So this helps in determining, this helps in determining the number of observations, the number of observations below a particular value, below a particular value, or within a certain range, or within a certain range. And you can see this information is very useful in computing things like the median, the mode for grouped data. So we need to always know the cumulative frequency before the modal class, before the median class, before the quartile, and all of those things. So that's why this is so important. Okay. So let's take examples. So talking about calculation, because not a big deal, just summing things up, right? Calculation of cumulative frequency, just summing things up, running total, like we've said already. Calculation of cumulative frequency now. So let's do for grouped data. I mean, for ungrouped data as usual. For ungrouped data, okay. So what we need to do is to start from the first frequency, start from the first frequency and add each subsequent frequency and add each subsequent frequency to the total, to the total. That's the previous total, so to speak. So look at this example. Um, so if we continue with what we had before, right? If we continue with what we had before, where we talked about the books read by students in the previous example. So you have read, books read. You have the actual frequency, and then you talk about the cumulative frequency, cumulative frequency. Okay. Frequency. Model that up a lot. Free frequency. Frequency. Okay. So we have something like this. So previously we had books read 0, and this is 2. Okay. We had 1, that was 5. 2 books read, that was 8. Then 3 books read, that was 3. 4 books read, that was 2. So talking about the cumulative frequency now. So start from the first one. Uh, so cumulative frequency here is 2. Then the next cumulative frequency will be this 2 plus that 5. That will be 2 plus 5, that's 7. And this 7 now plus 8, that is 15. This 15 now plus 3, that's 18. Then this 18 now plus 2, that will be 20. Okay, that's for cumulative frequency. So then number 2, right? We have for grouped data, it's just basically the same thing for grouped data. Now that helps us to know if this 20 does not tally. For instance, when I was transforming from ungrouped data to group data over here, we had 30 students, right? If the final cumulative frequency does not tally, then it means something is wrong. So you have to check, you know. So for grouped data, right, you have to do something similar. So it's just similar to ungrouped, but you accumulate, but you accumulate, uh, but you accumulate frequencies within each interval. Frequencies within each interval. Okay. So here now you have, okay, this second example like that we also did. So you have score range, you have frequency, then you have cumulative frequency. Most times you just write that as CF, cumulative frequency. Okay. So you have 0 to 49 appearing 4 times. You have 50 to 59 appearing 5 times. Okay. Then you have 60. I mean, this kind of grouping is actually useful because most times 0 to 49 can be taken as F. So 50 to 59 is C, and so on and so forth, depending on the system you're working with. Then you have 70 to 79. That is 3. Then you have 80 to 89, which is 2. And then you have 90 to 100, which is 0. Okay. So for cumulative frequency now, we can say, because the first one, so I mean, we've done this before. So the first cumulative frequency corresponds with the frequency of the first class. So you have 4. Next, 4 plus 5, you have 9. Next, 9 plus 6, 15. 15 plus 3, 18. 18 plus 2, 20. 20 plus 0, also 20. So you have that. So I also like to do for the one I just made up randomly when I was at it. Okay, I mean, let me just do it right here so I don't have to waste time. So if we just have a cumulative frequency uh table here, we can just do this. So, this is 3, 3 plus 7, 10, 10 plus 8, 18, 18 plus 8, 26, 26 plus 4 is 30. And that's how all of that goes. Okay. So let's talk about uses. What are the uses for these things we've been talking about? So let's talk about uses of frequency distributions, frequency distributions, and cumulative frequency. So first of all, they are good for data visualization. Data visualization. Interestingly, our next video is going to be about data visualization. So you're going to see how these things can be visualized. So data visualization. So we say that frequency distributions are often represented, are often represented using histograms, histograms or bar charts, or bar charts, making it easier, making it easier to visualize data. Okay. Then you have statistical analysis. Statistical analysis. Okay, I guess I want to color code here. Um, to statistical analysis. Okay. So frequency distribution and cumulative frequency actually help in calculating measures. In fact, we've done this previously, and that's why I keep saying this video should have come before we started all those measures and all that. But it's okay. You can fit everything together. So they help in calculating measures of central tendency, central tendency, like mean, median, and even mode for sure. Mean, median, and measures of dispersion, and measures of dispersion like range and variance, like range and variance. Okay. Then we have uh percentiles. We've done all of this in the past. So we have percentiles, which are measures of position. Okay. So cumulative frequency, cumulative frequency. You can see in the formula for calculating percentile, deciles, and all that. We always need the cumulative frequency before a particular class, and the frequency of the class itself. So we have cumulative frequency allows for easy calculation, for easy calculation of percentiles, which indicates which indicates the relative standing, the relative standing of a value, of a value within a data set. Okay. For instance, for instance, if a student's score, if a student's score is in the 70 to 79 range, it's in the 70 to 79 range. I mean, that's referring to this case now. So if a student's score is in the 70 to 79 range, you can see, you can see that 18 students, 18 students, so someone here, so you can see that 15 students scored below that range, right? You can see that 15 students, you can see that that should be 15, not 18 now. Because if you include the 70 to 79 range, everybody is 18. But before 18 now, you have 15 scoring below the range. So you can see that 15 students scored below this range, below this range. Okay. So those are the uses for frequency distribution and cumulative frequency. So understanding frequency distribution and cumulative frequency is essential in statistics as they provide valuable insights into data sets. They help identify trends and facilitate decision making based on data analysis. So these concepts are foundational for further statistical analysis and interpretation. And of course, just like you can attest to in previous videos, we have used these ideas already. Okay. So if you have not subscribed to this channel, there's so much more to go on statistics. And of course, there are many other playlists on different topics, set theory, probability, and the rest of them, calculus, and so on. So you want to subscribe to the channel so you can always get uh, access to this. And of course, hit the notification bell so you can always get alerted each time a new video is released. And don't forget to comment, like, and share. So till next time, have a great time. Bye.